So moving on to part two, hopefully for your derivative speak, you said since f prime of x is greater than 0 on negative infinity to 0 and f prime of x is less than 0 on 0 to 1, at the point 0, negative 1 is a relative maximum. A couple things I want to emphasize about the derivative speak, besides the fact that it's crucially important, and this is an AP thing, so that's why I'm really going to be a stickler about it. But keep in mind, when we're saying on, this is an interval. So I'm saying on the interval, negative infinity to 0. Notice that I'm using open intervals, right? Because that's what we have to be talking about when we're talking about relative mins and maxes. And then on the interval 0 to 1. But then this is a point, so I have to make sure to emphasize that. Okay, so the point 0, negative 1 is a relative maximum, but it's the intervals where it was increasing and then decreasing that made it a relative maximum. Also, I want to really emphasize the derivative speak is actually what we're using to justify that it is a relative minimum or maximum. The increasing decreasing chart is our tool to find where the function is increasing and decreasing via the first derivative. But this itself is not the first derivative test. All right, this is just a tool that helps us with the test. Okay, and it's what we call an increasing and decreasing chart. So that vocab is going to be very important because when we start seeing other tests that we have, it's going to be crucial that we understand what each test actually is testing for and how we apply that test. Moving on, I want you to try the next one on your own. So fx equals x cubed, find the domain, the first derivative, the critical numbers, make an increasing and decreasing chart, and then state the relative maximums and or minimums using derivative speak. Pause the video, unpause when you're ready to check. All right, so spoiler alert, we did actually kind of talk about this already when we talked about the definition of strictly monotonic, and this is an example of one of the functions I mentioned. So there are no relative minimums or maximums here, but we can verify that with our first derivative test. So first, the domain, all real numbers. Derivative, f prime of x is 3x squared, set that equals 0. Critical value is at x equals 0. So if I plug that into my increasing decreasing chart, another thing that's a good habit that I guess I didn't do on the first one, so I apologize, is when I'm making this increasing decreasing chart, actually label it. So I'm just gonna, so I know that this is f prime. This, I'm plugging things into the first derivative, and this is a critical value from the first derivative. So that's a good habit to get into so that I know what the chart is actually representing. If I plug in a number to the left of 0, I get a positive value. If I plug in a number to the right of 0, I also get a positive value. So therefore, this is not going to be a relative minimum or maximum, and it happens to be strictly monotonic. Next one. I want you to try this one on your own as well. So here's the function, find the domain, the first derivative, the critical numbers, the increase and decreasing chart, and then state any relative maximums or minimums using your derivative speak. Pause the video, unpause when you're ready to check. Right, so this one had a little bit more going on, but hopefully you found a relative minimum and a relative maximum. So my relative minimum is since f prime of x is less than 0 on the interval negative infinity to negative 2, and f prime of x is greater than 0 on the interval negative 2 to 0, the point negative 2 comma negative 89 thirds is a relative minimum. And since f prime of x is greater than 0 on the interval 0 to 4, and f prime of x is less than 0 on the interval 4 to infinity, the point 4 comma 1,423 thirds is a relative maximum. Okay, let's look at the work, make sure we understood how we get that if we didn't get that. So first domain is all real numbers, this is a polynomial. Fantastic. First derivative, just do our general power rule. I can factor out a negative 5x squared, and then I can factor x squared minus 2x minus 8 into x minus 4 and x plus 2, so I find my critical values by setting each of those equal to 0, and I get x equals 0, x equals 4, and x equals negative 2. Then I make my first derivative increasing decreasing chart. So I put my critical numbers on there, I pick values that are in between those critical numbers, I plug them into the first derivative and test if it's positive or negative. Notice that both of these came out to be positive, so that means that at 0 that is neither a relative minimum nor a relative maximum. However, notice that when I wrote my derivative speak, I didn't say the interval negative 2 to 4 was where f prime of x is greater than 0. In this case, I could have, but that's something you always want to be careful about. I would recommend that, just to avoid a mistake, um, just use the shortest interval, because this is sufficient for my explanation here on why -2 is a relative minimum. So I don't need to say from -2 to 4. And the reason why I'm cautioning that is, in this case, our domain was all real numbers, but we could have ended up where maybe there was like a vertical asymptote at x equals 0, and we could have noted that up here, but kind of forgotten about it by the time we got to this test. And then if we say -2 to 4 is where the function's increasing, that would actually not be correct, because the function would be undefined at 0. So it's something you got to pay attention to. And then same with here, I said it's from 0 to 4, not from -2 to 4. Just use the shortest interval, and then you'll avoid that kind of mistake. Okay, so in this section, we talked about Rolle's theorem and the mean value theorem. Both are existence theorems. They're great. The first derivative, if that is positive, then that tells us the function is increasing. If it's negative, it tells us the function is decreasing. If it changes from positive to negative or negative to positive, that tells us that we had a relative maximum or a relative minimum, depending on how it changed. That is our first derivative test, is using the positive or negative from the first derivative on an interval to determine if the function had a relative minimum or a maximum. To do that, we use what we call an increasing decreasing chart.